All right, so continuing the theme of substitution, what we're doing today builds on the U substitution. We're doing something called trig substitution today. Sometimes the trig substitution is going to be an identity, and sometimes it will be an inverse trig substitution, but it's very similar to U substitution. We're just swapping out one trig thing for the other trig thing. So just quick crash course. Give me some trig identities that you know. All right, so sine squared x plus cosine squared x does equal 1, and any of its variations. All right, so from that we can imply that sine squared by itself is 1 minus cos squared. From that we can imply that cos squared by itself is equal to 1 minus sine squared. So those are all true identities that come from the original Pythagorean trig identity. But there's some other trig identities that come from that. Do you remember the other ones that involve like secant or tangent or any of that stuff? I've showed you before how to come up with those. Okay, so take what you start with and do legal math by dividing everything by the same thing. So start by dividing everything by sine squared. If you divide every term by sine squared, that's legal. What would you get? Divide the first term by sine squared. What would you get? 1. Divide the second term by sine squared. What would you get? Cotangent squared. Okay, and divide the last term by sine squared. What would you get? Cosecant squared, because we're dividing by sine. So there's another one. That's true. 1 plus cotangent squared equals cosecant squared. Or if you did stuff to that, moved things around, you could also say that cosecant squared x minus cotangent squared x is equal to 1 as a subtraction. That would be true. So that's helpful. What if you went back to the beginning and you divided everything through by something different? Okay, yeah, cosine. So what if you divided everything through by cosine? You get tan first, cosine squared, I should say, plus 1 equals secant squared, right? Or the corresponding true statement would be that secant squared x minus tan squared x is equal to 1. Those might come in handy. So being fluent in those different trig identities could be helpful. Not to mention the trig identities of just plain old, like what's just tangent equal to? Tan over cosine, and what's cosecant equal to 1 over sine, like knowing those, that would be helpful. Okay, the other one are the double angle and the cheer. So you should know these two double angles. A double angle is sine of 2x. Okay, and that's equal to, no. Sine squared of x is equal to 1/2 plus 1/2 cos 2x. That is a helpful, true trig identity, and it can be proven with the cheer. Cosine, cosine, sine, sine, sine can prove that. Cosine squared, that's equal to 1/2 minus 1/2 cos 2x. They're both, like, it's not like the sine squared one has sine in it. They both do have cosine in it. They're both based on the cheer of cosine, cosine, sine, sine, sine. So the proof would be in using the cheer to expand that and prove that those, but I'll just know that those are going to be helpful to you in your homework. I should have maybe given you a slide to fit that in. That was not very smart of me. Okay, so here we go. Some of your integrals can't be done unless you swap out for a trig identity. So we've done tangent before. This is a basic trig identity. Swap tan out with what? Sine over cosine, yeah. Once we swap that out with sine over cosine, we're able to make a u substitution. So the trig substitution comes first, and then we would choose part of that as our u substitution. So with good practice is to choose the denominator. So choosing cos x as our u means that negative sine of x is our du dx, which implies that du by itself or dx by itself is what I want. Dx by itself is negative du over sine x. After that, it's the same as what you did. We're just preceding it with a trig substitution. So this would become the sine of x over u times the differential negative du over the sine of x. So we reduce and pull out the negative. So we'll end up with 1 over u du with a negative in front of it. So we have negative natural log absolute value u plus c, which is negative natural log absolute value of cos x plus c. So the antiderivative of tangent is the negative natural log of the absolute value of the cosine of c. If you want to memorize that, you can memorize it if you want to. Otherwise, you can just know how to get it in a pinch. You should be able to do the same thing with cotangent. So that's a basic trig identity where you're just swapping it out for its SOHCAHTOA value. Okay, here's another one. Sine cubed of x. Okay. You might start thinking, oh, I can rewrite that as sine of x quantity cubed dx, and maybe I'll make sine of x to be my u. Do you see the inherent problem? If you can see into the future a little bit, what's the inherent problem here? Nothing will reduce, right? We're going to end up with cos x as our derivative, but there's nothing to reduce. So that was a dead end. So go back. And what's a more helpful power for sine? Squared is more helpful. So try this. Try saying, how about sine squared times sine of x? That is a more helpful power to split a cube up into a square and a regular one, because the square has an identity. So I can do another swap, and I can put in 1 minus cos squared of x times sine of x dx. This is more helpful because now I have both a sine and a cosine present. And once I've got both of them present, I know that a u substitution will help me reduce one for the other. So I might choose something else now to be u. Yeah.
So sine equals 1 minus cosine.
Sine squared.
Yeah. And at the same time equals 1/2 plus 1/2 cosine.
That's another, yes. There are two different identities. One is sometimes more useful than the other. Okay. So now let's choose something else to be our u. So instead of choosing sine, let's try cosine. Cosine of x to be our u. Then we'll have the sine of x is our du dx, which means the dx is du over sine of x. So we'll see if that's going to be helpful to us. Okay, so now we're going to change cos x to u. So my quantity is going to be 1 minus u squared. So I'm just changing the cosine part. I keep the sine of x, and then I change my dx to negative du over sine of x. And there's where we breathe a sigh of relief. Okay, phew. We were able to do a reducing. I could pull my negative all the way out to the front, or I could just put my negative in with the other terms, like that. It doesn't matter, you get the same thing either way. Is that something you can find the antiderivative of? I think you should. I pass it to Josh.
Negative u plus 1/3 u
Plus c. And so then change your u back. And so the antiderivative is negative, and the u that worked was the cosine, so negative cosine of x plus 1/3 of cosine cubed of x plus c. So this is the antiderivative of sine cubed. Yeah.
How do you know to choose cos instead of the whole parentheses, like 1 minus cos squared x?
I think because we know that we're trying to get, again, you sort of have to use your looking ahead a little bit. We're trying to get something to reduce the sine x. So just by choosing a plain cosine, I know that that relationship is going to happen. So you pick the ones that are in relationship with each other. And then hopefully if you did accidentally pick the u, you would realize pretty quickly when you do your derivative and then move that, you'd be like, things aren't going to reduce. So pivot and pick something else. Okay? All right. Now, here is a really brand new thing. Do you know, slam dunk, what the antiderivative of this is? It's inverse cosine, yes. The answer is inverse cosine. And you only know that because I told you what the derivative of inverse cosine is, and you believed me. That I said, hey, this is the derivative of inverse cosine. It's this crazy square root thing, and it actually works. But I never proved it to you. So now I'm going to prove to you that this is the derivative of inverse cosine. Okay, this is the thing where you probably never would have, well, I shouldn't say never, but it's unlikely you would have come up with this on your own until somebody had showed you what it is. Okay? All right. Here's how the proof of this works. You want to make the best choice for you possible, and you choose it with the end goal in mind. I know my end goal is supposed to be negative inverse cosine. So that's what I'm going to choose as my u and see if it works and prove that it works. So I'm going to choose inverse cosine of x as my u. Okay, that's the first thing. The next is, before you actually take the derivative of that, I want you to get x alone. So how would you get x alone in that situation? Okay, and so what would that result with? If x is alone, then what do you know is true? X is cos of u. Okay, great. Now find the derivative. Dx is equal to, and then what's the derivative of the other side? Negative sine u times, not dx du, du dx. So this one goes away. So we have 1. And then I want you to get dx alone, like we have been. So getting dx alone means dx is equal to the negative sine of u du. Did you track with me on that so far? I just got the dx alone by multiplying it to the other side. But this all started because I declared that cosine, oops, don't like that, I want this, that, oh, here we go. I started with this. I started with the end in mind, and I picked that to be my u. It's all in the choice you make for you. It's going to be whether you're successful or not. Now we're ready to go back. If what I chose for you is true, oh my word. Root 1 minus. Instead of x squared, what do I know x to be? I picked x to be cosine u. So change your x to cosine u. So this is going to be cos squared u. Okay, I'll just swap. And then change your dx to what you know dx to be, which is negative sine u du. What can I do next?
1 minus cosine squared
Okay, 1 minus cosine squared
sine squared.
is sine squared. So this becomes the square root of sine squared u times the negative sine of u du. What's next?
And you can cancel out the 2 negatives.
Okay, I can take the two negatives and make them positive. What else?
Just becomes sine squared in the denominator.
It just becomes sine squared?
Sine squared u.
Just becomes sine, not sine squared. It's the
Oh, so
square.
that's what I meant.
Okay, the square root, yeah, so it's going to be 1 over sine u times sine u du. What does that become? 1. What is the antiderivative of 1? U plus c, right? And what did u stand for? Cosine inverse of x plus c. So we just showed, we proved that the antiderivative of negative 1 over the square root of 1 minus x squared dx turns out to be cosine inverse x plus c. We knew it was supposed to, but we just proved that it did, because we picked cosine inverse as our u. What if this had been a positive number from the beginning? Like a positive 1, what would you have picked as your u? Sine inverse. Okay, good. All right, let's try it. How about this one? Is to okay, so with that in mind, Gracie, what do you know you want to get here? Yes. With that in mind, you know you want to get cotangent inverse. So that means cotangent inverse should be what you choose as your u. Cotangent inverse of x as your u. And then rather than doing your derivative right away, you get x alone first. So x alone will be the plain regular cotangent of u. Then I apply my derivative. So my derivative is dx dx equals, and the derivative of cotangent u is negative cosecant squared of u times du dx. And then I reduce the dx dx, so I reduce that to 1. And then I get the remaining dx by itself. So dx is equal to negative cosecant squared of u du. And then once I'm done with that, I'm ready to go back and back substitute these two things. I put blue stars by them. I'll be back substituting cotangent of u for x, and I'll be back substituting negative cosecant squared of u du for dx. So I'll have negative 1 over 1 plus cotangent squared u in the denominator times in the numerator. Which takes you back to that. There's an identity for 1 plus cotangent of u. So we can go back to that very first one we did here. Okay, 1 plus, right here, 1 plus cotangent is equal to cosecant. So we'll end up with cosecant squared u in the denominator. And then we'll have two negatives make a positive. So we have positive cosecant u in the numerator as well with du, which gives me 1 du. The antiderivative of 1 is u, and u represented the inverse cotangent of x. And so now we've proven what I told you was true before, but now I've proved to you that it is true. All predicated on the best choice for you possible.